In this tutorial, we will create a rib inside the wing of the aircraft. Make sure you have the template file that was created for you, which contains the profile of the rib and some stringer gates. During this tutorial, the displayed model is likely to be at a different spanwise location to your model. Do not worry about this, as the procedure will be the same and the geometry will be very similar. When working in a collaborative framework within a group, it is always good practice to lock the data that you are responsible for. This prevents others from making unintended changes to your model and can save you from having to redo work. To lock a part, we will switch to the Collaborative Lifecycle app, which is used to manage the data on the platform. In the Collaboration tab, click on the Lock command. Then select the top of the tree. If the lock procedure is successful, then there will be a green key symbol. Switch back to the Generative Shape Design app to continue the tutorial. To start, we will create two geometrical sets to organize our geometry. Rename the first set to Main Feature References. This will be used to store the wireframe geometry created in this tutorial. And the second set to Extra Feature References. This can be used to store any extra features created in the next assignment. Now, ensure that the main feature references is the in-work object. In this step, we will extract the top and bottom curves of the provided sketch. In the Transform toolbar, click the Extract command found underneath the Boundary command. Select the top curve of the sketch. Ensure that the propagation type is set to no propagation, so only the top curve is extracted. Click OK to extract the curve. Repeat the procedure using the bottom curve of the sketch. In this step, we will create the first 4 points that will be used to create some planes in a following step. The points will be 45 mm from the ends of each extract. In the wireframe toolbar, click the Point command. Change the type to On Curve. We can use the lock symbol to stop the point type from automatically changing to help us when making all the points. Select the upper extract as the curve. Use the Distance on Curve option with a length of 45 mm. Keep the point as default to ensure the end point of the curve is used as the reference point. Click OK to create the point. Repeat the procedure using the upper extract again, but this time, reverse the point direction to create a point from the opposite end of the curve. Now do the same process using the lower extract as the curve. You should end up with 4 points. In this step, we will create 6 more points that will also be used to create some planes in the next step. The points will be 6 mm from each of the stringer gates. In the wireframe toolbar, click the Point command. Ensure the type is set to On Curve. Select the upper extract as the curve. Use the Distance on Curve option with a length of 6 mm. Use the end point on the rear side of the stringer gate as the point and ensure the direction is in the positive X direction. Click OK to create the point. Repeat the procedure for the other 2 gates on the upper extract. Repeat the process using the lower extract as the curve and the remaining 3 gates. In total, you should now have 10 points. Click Cancel to stop the command from repeating. In this step we will use the previous points to create planes that are normal to the curve at the points. In the wireframe toolbar, click the plane command. Remember that double-clicking the command will keep it active. Change the type to normal to curve. Again, we can use the lock symbol to stop the plane type from automatically changing to help us when making all the planes. Select the upper extract as the curve. Ensure the passing point option is used. Select the first point. Click OK to create the plane. Repeat the procedure for all the points, using the corresponding curve for each point. Click Cancel to stop the command from repeating. In this step, we will use the extracts to make two extruded surfaces that will be used to create flanges. In the Surface toolbar, click the Extrude command. Select the upper extract as the profile. Use a first limit type of length with a value of 5 mm. Use a second limit type of length with a value of 20 mm. Ensure that the 20 mm is in the negative Y direction. Click OK to create the extruded surface. Click OK in the warning message. Repeat the procedure using the lower extract as the profile. In order to use the extrudes correctly, we need to extend the edges so that they overlap the entire rib. This is done by extrapolating the edge of the surface. In the Transform toolbar, click the Extrapolate command. Change the mode to Curve Selection mode. Select one of the small edges of the upper extruded surface. Change the continuity to curvature and check the other values are the same as the image. Click OK to extend the surface. Repeat the procedure for the other edge of the upper surface, to extend it in the other direction. Repeat the process for the lower extrude as well. In this step we will set the parameters to be used for the sheet metal properties. For this we will use the Sheetmetal for Hydroformed Parts app, which is a specialized app used for sheet metal parts especially in the aerospace industry. Use the compass to change to the Sheetmetal Hydroformed app. In the Model toolbar, click the Sheetmetal Parameters command. Use the image on the left to set the correct parameters. Click OK to save the parameters. As you can see, a new item has been added to the model tree which contains the sheet metal parameters. Now that we have prepared all the wireframe and surface geometry, we can start the creation of the solid part of the rib. With most sheet metal parts we start with a web, which is made of a profile that is thickened to the default thickness of the sheet metal being used. Make the part body the in-work object. In the Model toolbar, click the Web command. Select the rib profile sketch from the external references. Use the default properties and ensure the material direction is towards the tip of the wing. Click OK to create the web. In this step we will cut the stringer gates out of the web. In the Refine toolbar, click the Cutout command. Select one of the stringer gate profiles. Keep both limits as up to next. Ensure that the cutting direction is correct and that it removes only the gate profile. Click OK to create the cutout. Repeat the procedure for the remaining 5 profiles. In this step we will use the surfaces to make a flange, however since we want to add a joggle in the next step to fit the spars and stringers, we will use the Surfacic flange instead of the regular flange. In the Model toolbar, click the Surfacic flange command. Select the web as the base feature. Ensure that the support type is exact and then select the upper extruded surface. Set the edge of part length to 15 mm. Ensure that the material and base feature directions are to the center of the rib. Ensure the Surfacic flange direction is to the negative Y direction. Click OK to create the flange. As you can see, the flange is a bent piece of sheet metal that follows the curve of the rib. Do not worry if your flange is created in a different section of the rib, just continue to the next step as we will add flanges on all the sections. In this step the joggle to be used for the 4 corners will be shown. A joggle can be described as the offset formed on a part to allow clearance for a sheet or another mating part. The use of a joggle maintains the smooth surface of a joint. In the Model toolbar, click the Joggle command. Select the Surfacic flange as the support. Select the plane that is intersecting the flange as the joggle plane. Ensure the plane position is set to end. Use the image on the left to set the correct parameters. Ensure that the depth direction is towards the center of the rib. Ensure that the run-out direction is towards the end of the rib. Click OK to create the joggle. As you can see, the flange has been pressed in to allow the rib to fit in the spar. If your first flange was created at the front of the rib, then do the same procedure using the corresponding plane, as the outcome will be the same just on the opposite side. In this step the joggle to be used for the stringer gates will be shown. In the Model toolbar, click the Joggle command. Select the Surfacic flange as the support. Select the plane that is intersecting the flange next to the stringer gate as the joggle plane. Ensure the plane position is set to end. Use the image on the left to set the correct parameters. Ensure that the depth direction is towards the center of the rib. Ensure that the run-out direction is towards the stringer gate. Click OK to create the joggle. Again, you can see the flange pressed in, but due to the inputs it is less as the stringers are not as thick as the spars. If your first flange was created at the front of the rib, then continue to the next step where the rest of the flanges will be made, as there is no stringer joggle needed on the front section. Keep in mind the values to be used for the joggle. Now that we know the 3 different procedures for the flanges, corner joggles and stringer joggles, we can make the rest of the flanges on the upper and lower edges of the rib. Start by creating a Surfacic flange on the next section of the rib using the upper surface. Check that the flange length is 15 mm and ensure that the material and base feature directions are to the center of the rib and the flange is created in the negative Y direction. Next, create a joggle with the parameters of the stringer gate joggle. If necessary, change the runout direction and depth direction so that the flange is created correctly. Continue alternating between creating flanges and then the corresponding joggles, remembering to change the directions in order to obtain the required flange and joggle geometry. The reasoning behind not creating all the flanges first and then creating the joggles is due to the fact that the flanges will need to be recomputed when a new joggle is added, and this can sometimes be quite time-consuming with all the calculations that need to be done. Remember that the last joggle on the upper surface is a corner joggle, and it has different parameters from the stringer joggle. Now that we have completed the flanges on the top side of the rib, we can continue to the bottom side and repeat the same procedure. Similar to the upper side, the material and base feature directions are to the center of the rib, and the flange is created in the negative Y direction. Note that the flange at the rear end of the rib has two joggles. In the end, each section of the rib should have a flange, and at each plane, the intersecting flange should have a joggle corresponding to a spar corner or a stringer. We will now add the final flanges to the ends of the rib. Since no joggles are needed and the edges are straight, we can use a simple flange. In the Model toolbar, click the Flange command. Select one of the vertical edges at the back of the rib as the spine. Set the length to outer length with a value of 15 mm to ensure it is the same length as the other flanges. Set the angle to inner angle with a value of 90 degrees as the rear spar is straight. Ensure the flange is created in the same direction as the other flanges. Click OK to create the flange. Repeat the procedure for the flange on the front of the rib, but use the calculated value of 97.57 degrees as the front spar is angled due to sweep and the taper. Looking at the corners of the rib where the flanges meet, we see that this area will have problems during manufacturing and will have high stress concentrations. Therefore, we will need to remove some of the corner using what is known as a corner relief. In the Refine toolbar, click the Corner Relief command. In the pop-up, click Yes to enter the unfolded view. The unfolded view shows the template of the part needed before it is bent into the correct shape. Select the two flanges adjacent to each other on one of the corners of the rib. Ensure a radius of 3 mm is used. Change the center type to Bend Axis Intersection. Click OK to create the corner relief. Repeat the procedure for the remaining 3 corners. Use the Fold-Unfold command to return to the folded view. As a final step, we will add alignment holes which are generally used to place the part in the correct position during manufacturing. Create a position sketch on the face of the rib. Create 2 points in the corners of the rib as shown in the display model. Constrain both points 20 mm from the corners of the rib sketch in both the horizontal and vertical direction. When creating the constraints in the sketch, right-click to set the length to be in the vertical and horizontal direction. Exit the sketch. Now select one of the points, then in the Refine toolbar click the Hole command. Select the face of the rib to place the hole onto. Set the limit type to Up to Next and the main diameter to 6 mm. Repeat the procedure with the second point. Similar to the first tutorial, we will add a drawing to the part, rename it and add a description. In this part of the tutorial, we will create the preliminary detail drawing for the wing rib. As always, we start with the page layout. Make sure it is set to the ISO/TU Delft standard. Set the page to any size, as we will use the resize later on when we update the layout. This time we will create the title block to see what happens when there is no view already created. click the Apply button and fill in your name. Then click the OK button. As you can see, the title and description have not been filled in. We will update this in a later step. In this step we will create the orthogonal views, but instead of using the wizard, we will use the front view command and the projection command. In the View Layout section, click the Front View command. Switch to the window with the 3D model. Select the face to be used for the projection. Use the View Rotator to orient the view. In this case we will put the leading edge of the wing on the left side. Click in an empty space to create the view. Next we will create the other views using the projection command. It can be found in the contextual toolbar when you click on the frame of the front view. Position the view and then click to create it. The projection command can also be found in the drop-down under the front view command. Create the left, right and top views using the projection command. In this step we will create the unfolded view, which shows the sheet metal in its unfolded state. In the View Layout toolbar, click the arrow on the right-hand side of the toolbar to extend it. Click on the Unfolded View command. Switch to the window with the 3D model. Select the face to be used for the projection. Use the View Rotator to orient the view in the same orientation as the front view. Click in an empty space to create the view. As the name suggests, you can see the flanges have been unfolded and flattened out, showing the piece of sheet metal required before it is bent into its final form. In this step we will resize the page, update the title block, reposition and align the views. Open the page layout again. Select a page size that is appropriate for the size of the rib at a 1:1 scale. When changing the page size we can use the resize option to recreate the title block. Use the Apply button to set the new properties. If you do not resize the page, you can use the Update option to update the properties of the title block. As you can see, the title and description get updated for you. If the description is empty, remember to adjust it in the properties of the part. Reposition the views on the page, making sure they fit inside the border. In order to precisely align the front and unfolded view, we need a corresponding element in each view to align with. The centerline of the alignment holes is a good reference, so add the axis and centerlines to all of the views using the Properties tab. Now make sure to only have the unfolded view selected. Right-click its frame and under the View Positioning menu, select the Align Views using Elements option. Select the vertical center line of the alignment hole in the unfolded view. Then select the corresponding centerline in the front view. This will align all the elements in the unfolded view to the front view.